So I have my length, width, and height for my cooler. I have a fillet on the corners, I have a fillet on the bottom edge, and next I'm going to shell. Now the shell value is going to be 0.5, and you can really think about this as just a styrofoam cooler. I mean, nothing fantastic, but we just have a nice rounded bottom styrofoam cooler open container. And what we want to do is we want to figure out the volume of it. There are several different ways that you can do this. You can do it with surfaces, which is usually the go-to method if you've been around SolidWorks for quite a while, since at least before 2013. And there's other methods that you can do, but this is where making the top plane the top of my part is going to make sense. Now I'm going to hold down the control key and I want to drag this plane. I'm going to drag it down 1/2 inch. I'm going to actually input that dimension 1/2 inch. And what I've done is I've made an offset plane from the top, and this is going to represent the top of my fluid. Now the reason I'm doing this with a plane is because now I can go into Insert, Features, and down to Intersect. Now Intersect has some great options for me. Plane is still selected. I'm going to select the body, and I'm going to take a look at creating an internal region, and then I'm going to say intersect. So what we see on the screen here is the outside body as well as the new inside body that's created. Now there are some options to exclude regions if you want. We can merge the results, consume any surfaces. In this case it's a plane, so it's not a big deal. But if you drew a surface that had some geometry to the top of it, you might want to consume it and delete that in this feature. But intersect essentially takes 4 or 5 steps of the process and puts them in one feature. Very easy to use. Now I can hide that plane, and now I have an internal solid volume that matches the inside shape of our part. The great thing is, anytime we change a dimension, for instance, if we change the height of the cooler to be, in this case, let's go to 7 inches. The top offset for that plane is still 1/2 inch below. And that's why I ended up flipping the extrude and using the top of my part and the top plane is the same. So now I'm going to go into my solid bodies folder. Intersect 1, I'm going to rename volume, and intersect 2, I'm going to call this cooler. I also want to make sure that the inside's transparent. I can also change the color if I want, or the appearance, but really I just want to make sure that it's very apparent that these are two different solid bodies. So now's the fun part. Now in the past, if you have ever tried to design something that had a fluid volume inside of it, you've more than likely done this process of making a core or the inside, and you've probably gone to your Evaluate tab and gone over to measure the mass properties. You can select that solid body, you can look at the volume, in this case 3.23 gallons. But let's say that you want to make a change. We're gonna modify the cooler. We're gonna go back to 6 inches. We're gonna rebuild this thing. And to get that volume again, you gotta go back to mass properties, back to select it. See, now we're at 2.68 gallons. Well, with a sensor, we come to this folder, we'll right click and we'll add a sensor. Now by default it'll be on mass properties, but there's a lot of extra stuff in here. Simulation data, which we'll take a look at in our second module. We can look at dimensions, we can look at measurements, and we can even look at costing data. Now for us, mass properties and specifically the volume are going to be what we want. Now you notice it shows us a value, 2.23, and a lot of extra decimal places. So this is great because it's going to constantly keep track of that for us. Now in this case, if we weren't going to do a design study, we could turn on an alert, and anytime we made changes to the model, we could have it alert us if the volume was greater than or less than a value, not greater than or less than, or exactly a value, or between a value. In our case, alert doesn't really make much sense, but that is nice if you're using sensors just during the modeling process. So now if we expand the sensor folder, note that it has our volume directly in here. It's directly inside of the tree. So any changes we make, this goes out to 12 inches, we rebuild it, we now see that we're up to 3.28 gallons. So this is a very handy tool, not just for this case, but for lots of other cases if you really need to track something. Now, dimensions and measurements are very handy, especially if you're designing a product. And again, you need to keep it within a certain build volume. So keep in mind that sensors have lots of other uses outside of what we're doing here.